So section 1.4, this is really important. Probably the most important section in chapter 1. Using limits to find tangents. Now you'd say, well, haven't we been doing that, Mr. Maxwell? Well, the fact is that we've been talking a lot about limits. And yes, we've been thinking about limits and thinking about tangents and how they're connected. Now what we're going to do is we're going to utilize everything that we've learned in the last little while. So all this stuff that we've been doing, and specifically like something like this, right? This is a straight limit, okay? And I'm going to show you how this is going to be used to find the slope of a tangent line. So we've been finding limits here, and now we're going to connect the two. So we've got a tangent, okay? So we've got, where's my graph here with a tangent? Let's just go back. Okay, so there's my graph. Here is a tangent line, right? And I'm going to use the concept of a limit, and I'm going to actually calculate, using limits, the slope of a tangent line. Okay. So if you look on page 30 of your text, that's where we are in the Stewart text. Using limits to find tangents. So I want to just quickly draw a graph here for you, something similar to what's in the textbook. And let's say that we have A right here. That's this x value. It's A, and this is the point where we're trying to find the slope of the tangent line at this point. Okay, and let's say we have another value, another x value that we'll just call x. Okay, and let's say, let's see how this is going to work. Okay. Let's just say that if we want to find the slope of this secant line here, right, the line connecting 2 points on the curve, then how would we do that? Well, we have to first look at what the coordinates are. The coordinate for this one is A, and what? If that's A, what's the y coordinate? And we can't just put y. Not B. F of A. So it's the function evaluated at A. So the coordinate of this point is A f of A. Yes, very good. Okay, what's the coordinate of this function over here? X and of x. Okay. And the slope of this line, right? The slope of that line, that secant line, would look like this. Change in y over change in x, which would actually be written as f of x minus f of a, those are the two y values involved, divided by x minus a. That's the difference in the x values. Are we agreed there? Does that make sense? Okay, difference in y divided by difference in x. Okay. Now, what did we say about the slope of this tangent? We said that as these points get closer and closer together, the lines connecting the 2 points are going to start to approximate the slope of the tangent, right? So now, well, all we have to do, and this is not that difficult, I don't think, but we have to take this, what would be the slope of, oh wow, that's weird. I accidentally hit a button there. The slope of this black line right here, right, that's the slope. Now, if I let x get closer and closer and closer to A, whatever this x value is, like if it's, we're going to give it a number here pretty soon. But if I let x get closer and closer to A, then this slope is going to get closer and closer to the slope of the tangent line. So this is what we have. The slope of the tangent line at x equals A, so that's this A value right here. Okay, that's this one right here, or this point right there, is represented by the limit as x approaches A of the representation of the slopes of the lines that contain x and a, for f of x minus f of a divided by x minus a. So this is one of the main formulas that we're going to use to calculate slope. So here's the slope, difference in y divided by difference in x. And I want to know what this slope looks like as x is brought closer and closer and closer to a, which is just the same as the limit questions we've been doing last section, right? So you know how to do the math. Now you're connecting sort of why we're going to, or how we're going to do this, find this tangent using this limit. And so let me give you an example. Let's say, well, let's just keep that in mind here, and let's do an example. Like, okay. All right, here's the function. It's y equals 2x squared plus 4x minus 1. And what kind of graph, what shape is this? Yes, a parabola, very good. And I want to know what is the slope of the tangent. So what's the slope of the tangent at x equals 2? Now remember that this point in question, this x value in question, is actually equal to a. Okay, that's our a value. So if we're looking at a diagram, which we'll draw a diagram here real shortly, and you can get your graphing calculator out if you haven't already. You can come up and grab one. While you're while you're quietly doing that, quieter than I just did, I will plug this in. So it would look like this. Would be y equals, clear that up, 2x squared plus 4x minus 1. And we'll graph that. What does that look like? It should be a parabola. See, there's the parabola. And x equals 2. Let's do x equals 2. And the point is 15. Okay, so let's change that window so that our y max is a little bit greater than 15, so we can see it. We'll calculate our value of 2. And here's 215. See that? So we're really looking for the slope of the tangent line as it just touches this point on this parabola. So it's going to be pretty steep, isn't it? It's going to be pretty steep. It's going to be a large slope, a large positive slope. Okay? So we'll just take a little clip of this so we have an idea of what's going on. And we'll just paste that right there. Make that a bit bigger. Over. Okay? So this is not going to be a very good line, but let's just say this is this tangent line right here. Okay? Touches one point right there. So that's what we're looking for. All right. So if we go back to our formula to find slope, this is what we're going to do, right? F of x and f of a. Well, f of a in this case is actually f of 2, isn't it? And what is f of 2? Well, it's just whatever the evaluation of this is when x, or when 2 is put in for x. So it kind of looks like that. Let's see, what is that? Oh, I didn't put a 2 there. Sorry. So that's 8 plus 8 minus 1 is 15. That makes sense. There's the 15. In some questions, you're not going to be given that second coordinate, so you're going to have to find it just like I did there. So f of 2 is 15. Okay. So our limit function, limit as x approaches 2, because that's our a value, of f of x. Now, f of x is just the actual function, so we're actually going to put that in there. So 2x squared plus 4x minus 1. See, it's the y value, or f of x with x put in for x. So that's just like that. So there's f of x minus, what's f of a? 15. So recall, we've got f of x minus f of a. That's on top. And we're going to divide that by x, and that always just stays x, minus a is 2. Okay? Well, you might look at all these brackets and say we should simplify that, which you're absolutely right. And it is important, by the way, that you re-copy out this limit x approaches to every step. Okay, every single step. Please do not lose sight of what you're doing. I've seen students do this and just not write this out again, and just copy this down and just simplify this, and then they get to the end and they have no idea what they're doing, or they forget by the end. They're trying to find a limit and they get lost, really. So I'm going to get you to copy this down every time. That's why mine gets pretty messy, because I've written thousands and thousands of these. So how can we simplify this? Well, that's going to be 2x squared plus 4x, and we're going to have negative 1 minus 15 is going to be negative 16 over x minus 2. Then you say to yourself, okay, could I just plug 2 into the equation here? Well, no, we're going to have a problem right here, aren't we? Okay, 2 minus 2 is 0. In the denominator, no good, which most of the time you're not going to be able to do that, right? I mean, all the time we use this equation. But what can we do? So what do we do if we run into this problem? What have we done in the past? Simplify, factor, yes, all of that. So factor the top, factor the bottom, and try and simplify. Try and divide out any common factors. So let's do that. And what I can take out a 2 here, I see. X squared plus 2x minus 8. X minus 2. Can I factor this trinomial here? Let's try and do that. I think we probably could. So what's that going to be here? We need two numbers that multiply to negative 8 and add up to positive 2. What do you suppose that might be? Positive 4 and negative 2, you guys agree? Correctamundo. That's really nice because, check this out, we've got x minus 2 and x minus 2, don't we? That's gone. So, limit as x approaches 2. This actually simplifies to this, 2 times x plus 4. And now, while you're doing this, now you can plug in your x equals 2 in here, and now you can drop the limit, okay? So this is important. Once we've simplified, divided out any factors, remember that when this factor is divided out, the graph actually looks just like this. Now we're going to have some kind of gap here, but if you plug x equals 2 into this, what this graph actually pretty much looks like, you're going to find out what that value in the gap is, you see? Now that I've gotten rid of this factor, you're going to actually be able to find out what this number is. That's why we can just simply plug the number in once we've simplified, because that would represent a gap. And what would the gap be, or what would the number in the gap be? Well, you can plug it in. So now you go like this. You go 2, and you plug in your 2 in for x. And that's 2 times 6 is 12. Okay? So your limit is 12, see? The limit is 12. And you can write now the slope of the tangent line at x equals 2 is 12. Okay, so that's your answer. Okay, and yeah, so you go back here, and well, it should be a pretty high, slope. 12 actually is pretty high. What's this point again? This is 215, right? So I'm going to show you something here. Here's a good check, and to get to know how to use your calculator and to use your graphing calculator with ease, this is a good idea to do. Y minus y1 equals m times x minus x1. This is the point slope form, right? So what we're saying is that the tangent line, the equation of the tangent line, should look something like this. Y minus 15 equals 12 times x minus 2. Right? So let's just simplify this a little bit. It's 12x minus 24 plus 15 is going to be 9.